Great. That's a pretty compelling speech by the Palo Alto Networks founder. You know, we actually are living through that right now. Just a little bit behind those guys. So fascinating, some of the comments there. I love the closing line that when you disrupt an incumbent, they really don't have any options. I'm only going to spend a few words on violent memory today because they asked me to talk a little bit more about big data, which is the panel we're going to have next. And I think in the big data space, we spent the last 7 years building a couple of companies to make it possible to put every piece of data you have in your enterprise in memory. We used to call it the Silicon Data Center. We used to call it the Silicon Storm over the last 7 years as I spoke all around the world. But I think the moniker going to be used today by Gartner, by Oracle, is going to be in-memory computing. And that is your ability to put everything in a set of memory technologies, DRAM, NAND flash, arrays, and make them available to you to go do big data type analytics. And I think the first use case is not just big data, but big fast data, which is really driven by the mobility trend we all talk about over and over. And then I'll talk about my third project. You know, I've had $2 billion back-to-back projects in a row. My third one we founded 20 months ago. We decided to apply these techniques of in-memory and big data, real-time analytics to what I think is the next big area of social, and I've termed it social commerce. We'll talk about how social commerce and a company we created, BizBliz, has grown from 0 in 20 months to hold billions of records, to go hundreds of millions of transactions, and to actually democratize commerce on the internet for you as the individual. So I'll say a few words on that as well. But I think we all talk about over and over again the forces sort of driving the enterprises today. And the last two companies I did, the one I run today, Violent Memory, is all about making these trends available in real time at scale. Okay? And whether that is the mobile type data that really is taking over our lives, whether it's the explosion of information that have to make decisions on with virtualization, these things really drive the enterprise infrastructure, and they're forcing the enterprise infrastructure to change. You cannot service them with the infrastructure of the past. You actually have to change that infrastructure. And I think the most important trend in that is the trend towards in-memory computing. Okay, and big companies talk about it, small companies talk about it, but in the end, if you can put every piece of data in your enterprise, in-memory access it randomly, you would do it. And what I'll tell you, and I'll show you on a slide in a minute, is almost every enterprise can do it today for not very much money. In fact, over the last 7 years, these companies have already been created. I don't think any more will be created. That can actually put it in today at a very, very, very reasonable capital cost. When you move things in memory compared to using the infrastructures of before, the disks, you reduce storage, you reduce servers, you reduce software licenses, you reduce floor space and power for the old applications. But more importantly, you unlock a whole new set of applications that you write differently and more impactfully. And that's really what's underneath a lot of these different thrusts and big data type data structures, NoSQL, in these types of applications. So how do you make that possible, right? So I've been on a progression for 7 years. Many of you know Fusion.io, which is now a multi-billion-dollar public company. Violent Memory, across these two companies, thousands of companies in the world have begun transitioning into a full in-memory infrastructure. Some of them are already there. Companies like Tag.com in the social networking space run 100% in memory today. Some of them are just on their evolution. As we move forward, we're both creating clouds, like the Float Cloud company, and then creating applications that show what happens if you program completely and consistently around all in-memory infrastructures. And the one we picked to do, because you can't do too many things, was the social commerce one. And I have a quote up there that's from Pat Gelsinger, who now runs VMware. And he says, if you look at the data center of today, you see a museum. The museum in disk, a museum in old-time networking gear. Servers aren't going to change much. You see that museum. And the new companies, I think the new opportunities are about programming to the new infrastructure. Get ahead of that. So we work with all these types of properties. What would it take for these properties to go in memory today? How about the top 5 banks in the world? What does their infrastructure look like? What is their big data? A major bank has accumulated 200, 300 petabytes of data over the last 50 to 100 years. Okay? That's all they have. That's their whole infrastructure. Okay? Today, a rack of memory arrays holds about 1 petabyte. Ship it today off the truck. You only need 200 to 300 racks to hold every piece of data, put it in memory of the biggest banks in the world. You can do it for $1 billion. It's nothing to these guys on the IT spend. So today, any major bank in the world, any minor bank, could go completely in memory. They haven't yet. Some of them are starting it. But that's how easy it is. When I say the problem's been solved, it's been solved for those guys. Large-scale web properties, not the hyperscale guys. We're going to get those in a minute. 100 million users, 300 million users like tag.com. You know, they have a petabyte, maybe a couple petabytes. You can put them in 2 6-foot racks and run the entire infrastructure. It's not a lot. Hundreds of millions of users interacting, 60 to 80% mobilely and socially. Couple racks. Sorry, I left the 1 billion up there. A few million dollars. Hyperscale, still a problem we haven't completely solved. Hyperscale guys are looking at. The hyperscale guys, there's only a couple of those companies in the world, you know their names. Hyperscale guys actually have thousands of petabytes. They've blown by the banks. They've blown by everybody. They've accumulated most of that data in just a couple of years. These are phenomenal infrastructures. Many of you have probably seen the data center report on Apple, going to spend $8 billion in their data center this year. And they're growing rapidly. To get them in memory, though, is possible, but expensive. It takes about 1,000 racks today to solve the entire problem. That's good. I think Google just built a 1 million square foot data center. They can fit 1,000 racks. But over the next 2 to 3 years, in every one of these cases, the memory technologies are going to go to roughly 10 petabytes per rack. Right? So think about that. We're going to shrink by 10x the physical footprint necessary to hold all this data in memory. And in reality, if you separate the video from all the non-video, everything that's not video is relatively easily put in memory today, even by a hyperscale data center. We'll talk about video later. Then the other big users of data, they're probably 1,000 petabytes today, the major telcos of the world. We're not sure which way they'll go. First of all, we absolutely can put them in for $3 to $5 billion a year of CapEx, all in memory. That's nothing for a telco, spending CapEx. It's nothing. It's trivial. Now, they may go like the hyperscale guys and get into the business of video. These guys have $100 billion CapEx budgets when they do fiber rollouts. Right? Or they may not. In 2 to 3 years, if they don't go hyperscale, you fit them in 100 racks. All the telco data, the major guys in the world. So the in-memory problem in terms of technology really has been solved. It hasn't been deployed yet, it's been solved. And it now allows you, no matter what you run, if you run anything smaller than this, imagine how cheap it is for you, to go think about programming your business as an in-memory area. Okay? So, having kind of done that for a couple of years, we said, what else can we do? And what can we do to take advantage of this trend that we help participate in? And we said, well, advertising makes a lot of money on the internet. Everyone knows that. That's pretty well done. Can't really do that. Mobile's driving a lot of differences in real-time decision making. In fact, it's changed the way we all behave, whether you have your iPhone or your Android. Okay, you want it to be local. You want it to make decisions on geography, what you're doing. And then you have another problem. This screen is tiny. You need incredible relevancy at that moment in time, which you have to compute somehow. There's 1 billion smartphone users already. Over the last couple of years, and I think we've seen many of the reports, it went from near 0% on these networks to 60 to 80% use on the mobile device, okay, for access to them. So how do you make big data decisions fast, relevantly? The mobile internet heading to 10 billion users, a scale problem we haven't solved before. So we looked at the difference between advertising revenue and commerce, and we said, you know what? One of the biggest problems that exists on the internet is capturing the economy. Not for the big stores like Amazon. They capture it from you. But if you're a small business, if you're one of those people that actually wants to run a side business, how do you get on the internet, drive revenue, drive transactions, and do it? Well, if you have a couple $1 billion, you can go build an Amazon infrastructure or a Google infrastructure or Facebook infrastructure. But if you don't, you can't get on there. And if you go on one of those networks, they take all of your people. They take your networks. They use them. Okay? What does it take to go ahead and build a social commerce infrastructure. How complicated is it? We know it can be built for billions of dollars. So we set out 20 months ago to go build a pure silicon commerce infrastructure that you can rent for $10 or $20 a month. That has the same characteristics of an infrastructure by a major commerce vendor. Okay? Everything you need: intelligence, traffic, marketing, funnels, products, protection, emails, data buying, scale, billions of records. How do you go do that and make it possible? Okay? What did it take to get us there? Well, today in 20 months, we have over 2 billion opt-in records, permission-based records to market to you, to email to you through this network. Okay? We have a real-time ability to go hit every one of those records. We can generate over 30 million emails an hour. If we want to, we can make it 300 million emails an hour, or social links. We've already transacted over 190 million credit card transactions through the infrastructure in the period of time. In doing that, every single packet that comes in is looked at and redirected. If you don't want a packet from China, you don't get one. If you don't want to click, okay, you have to make decisions in real time across billions of sets of data. If you want to block someone, you want to change someone, all done. Today, to do that, there's not the video side, 400 terabytes and growing, linearly scalable, rapidly growing, full in-memory analytics, full upsell, full metrics. And what makes it social? Well, think about the infrastructure we're moving online. The infrastructures we're moving online, they used to be called Avon. You know what Avon is? Person-to-person selling. It used to be called multi-level marketing. Okay? Noni Juice, New Skin, where individuals sell down their networks. Today, you don't have a mechanism to sell down your network. You don't have a mechanism to put up a store. You don't have a mechanism to go down the Facebook graph. To do that, you have to get access to traffic, to sites. You have to get affiliate commissions paid. You have to monetize that. You have to do credit clearing. Trivial for Amazon, trivial for Google. You're a 10-person shop, a 1-person shop. Impossible. You'll be shut down in no time. And so our view was, can it be done? I think it's now been done. And we think that this trend is going to be the most important trend. So 20 months ago, I served as chairman of the board. We co-founded that. We used a next-generation venture fund. Because normally next-generation venture funds think about things called 7 Peaks that got ahead and produced capital for us. We're about to go ahead and solve this problem, 100% silicon infrastructure. Okay. There's one more problem left for me to work on next. And when I was here speaking about 6 months ago, we announced that we did a founding partnership with the San Francisco 49ers at Violin Memory. And that's really great, and it's a beautiful stadium being built in Santa Clara. It's great marketing. But for those of you in the Valley, you know that the president of the 49ers is a gentleman named Gideon Yu, and the CTO is a gentleman named Kunal Malik out of Facebook. And in this stadium, over the next 2 years, we're going to attempt to solve the mass video problem locally. Provide every person in the seat on their mobile device 100,000 rough streams of HDTV across 26 cameras, captured, edited, stored, socialized, modified, Instagram, whatever you want to call it, and available to you. So your experience in stadium, in game, is better than anything you've had before. A mass data problem, a mass big data problem. We'll let the 49ers worry about the rights issue, not my issue, but technologically solve the issue of mass user-generated data. Right? Movie data is easy. Okay? 4 gigabytes times 10,000 films, trivial to solve. User-generated content off HD cameras, very difficult. A major problem going forward is people want to socialize around video. So we thought this was a great test case, a great building case to go build the big data problem around video and locality. And you can think of, I think here, probably 100 things you can go do with that. When you have masses of people in stadium after stadium, generating content, experience, data, marketing opportunities, all those things. And that's really the next side of the big data opportunity that we go. You got to be pretty fast to do that. It's got to be very quick to do that, to go ahead and edit that and move it. And that's really a great problem for us. So when we think about this explosion of big data, and we're fortunate enough to work with all kinds of things in the moniker, whether that be little new companies that make Cassandra or MongoDB or HBase or Hadoop or or very large companies like one of our investors, SAP Ventures, that make HANA and other next generation technologies. As you talk to them more and more, they're realizing that rewrite your software, rewrite your application, rewrite your assumption that you never have to deal with high latency, stream-based access. Every single piece of data you have and you've ever collected is available very inexpensively on a relative basis to any infrastructure built before. Every piece of data. And if people choose to do it, if they choose to open the data streams, as Twitter did for a while, you could access every piece of data randomly over the internet and build application after application after application. And I think as we look forward, the infrastructure problem is largely solved. It's only billions or tens of billions of dollars to spend away. The opportunity, though, to do that in real time, analytically across this data set, the opportunity is very, very broad. For every piece of enterprise software, consumer software, commerce software, video application, editing. And that's really where I think that the next challenge in big data is moving. And how do you take advantage of an assumption that goes forward there today? So unlike your previous speaker, I have a short talk, and we have a panel. So thank you very much.